Good day, everyone. So, on behalf of my co-authors, I will be presenting our paper entitled Mass Patrol, a generalized framework to track marine litter, fair, and call. So, I am Jazzie Jao. I am part of the faculty of the College of Computer Studies at De La Salle University, Philippines. So, I'm the only one who's here, so my co-authors, one of the co-authors is here as well. So, just to introduce them formally. So, before that, this presentation is divided into three parts. So, introduction and objectives, the methods, and the results and summary. Originally, this paper is accepted as a poster contribution. So, Professor Hirpa just asked me to present this as one of the sessions. So, it's not quite detailed because we are still working in the process, but the important thing is for you to see what is the framework that we are currently using in our laboratory in the Philippines. So just to introduce my co-authors, I have here myself. So I'm working, that's me from Physics and Computer Science as a physics major. Dr. Volker, the second one, works on Physics and Environmental Science. We have Dr. Marlon Era from Social Science, Business Project Management is Ms. Jazzie Jao, and Mark Lanyana from Social Science. So why do I presenting these authors? Because our framework is composed of different fields, because we try to create a framework that can be used for managing marine litter. So, what is marine litter? There are many definitions of marine litter, but we are just taking one of these. So, it's any materials that have been discarded, disposed, or abandoned in the marine and coastal environment. And the most prevalent form is plastic waste. According to statistics, 12 billion metric tons in landfills or natural environments by 2050 is predicted, and it could potentially populate oceans with at least 5 billion particles if current management proceed as they are. So this suggests that waste management on land can potentially contribute to marine pollution, so they're interconnected. Now, the problem is, plastics tend to remain in the marine environment for a longer period because of their durability and, in general, ability to degrade slowly. Therefore, the possibility of these materials being observed around various oceans is highly likely, and their accumulations impose economic, environmental, human health threat, and aesthetic problems as well, specifically for those areas where tourism high tourism numbers. Now, and aside from that, also the fisher folks, we are well aware that marine litter management is a problem not just in one area, because we share the same sea and the same body of water. Therefore, we are all affected here. But to be specific, in my country, the Philippines, marine litter is becoming a growing issue, and its consequences have already been felt. So some pictures here are taken from different. This is from one of the rivers in the Philippines, and also the lower part of that one, I think it's from one of the coastal areas. While there are existing efforts currently done, as marine litter path is a well-established problem already, using computational solutions, we want to create or present a framework such that the requirement of non-singular solution of marine litter management is addressed. So one way to do this is through collaborations between different fields. And this study, it's an ongoing study, aims to contribute to these existing models by introducing a framework that is consisting of 3 pillars: the computational, social, ecological, and economic arms. So with this, we have 3 objectives here. So I already mentioned the first one. So in the second one, we simulated the path of a chosen marine litter. In this case, it's the plastic, using the Norwegian Ocean Dynamics framework in Python, so that's parcels. And we applied this simulation on a specified marine area around a region in the Philippines. So this is the framework. So we are defining 2 new terms here, which is the fair and the call. We already know what the path is, and we have several methods on how to do that. One way to do that is to use the Lagrangian particle tracking model to model the spatiotemporal behavior of litters on the surface of the ocean. Now, the new term here is the fair. So this fair component is the direct and indirect effects of mesoparticles on sea and land populations while they wait to accumulate on shorelines and other settlements. So this is the ongoing process wherein marine litters are currently in the ocean. So we also need to quantify this one. Why? Because several marine environments are affected, like the turtles and other animals. On the other hand, we also have the toll. So this toll is examining the long-term ecological and socio-economic cost of ecosystems and land, as well as the damage and loss in gross revenue from the marine sector when marine litters penetrate habitats and livelihood in the long term. So we have to define this one. What is our long-term frame and what is our short-term frame when we tackle this marine litter management? So you consider this specific condition or area in the region of Visayas in the Philippines. So as you can see here, this is the Visayas region. This is the middle part of the Philippines. So we artificially generated litter data around this region, and we focused on mesoparticles only because the medical description for micro and nanoparticles requires a different domain, so we want to simplify it like this first. And the particle trajectories, as you can see here in this equation, is modeled using the solution of this one, where x of t, vector x of t, is the position of a particle represented as a vector with x and y components at time t. Now, we employed a daily interval of delta t is equal to 12 hours, and the time integration is done using the fourth order Lugge advection scheme. During the simulation of these particles, several particles are pushed ashore along the coast and remain within a radius of 12 consecutive hours, and it will be treated as water meters floating around this area. And we practice one within a 300-day period, so that's almost 1 year. And we also captured the spatiotemporal data according to a maximum range specified around selected coastal locations, which we will see later on. After path identification, it is expected to have several displacement locations. Now, we use DB-scan or density-based spatial clustering to reduce the number of data points through first partitioning this group of particles and calculating a centroid. Now, you can see in here the result of the DB-scan algorithm for selected simulation days. I'm not sure if it's evident, but it's from day 1 to day 30. And we can see in here that the highly dense collection of data are treated as one cluster. So these cluster movements serve as the basis in calculating a representative point that we will use later on to plot the litter path on the chosen frame. So the simulated classics are tracked forward in time near the specific areas. So these areas are the most populated islands in the Visayas region. There's a lot of hills in here. And we carry the following assumptions. First is their weights, shape, and chemical compositions are negligible in their dynamics of the field data itself. Shown in the slide are the day 3 to day 8. That is, we can see in here that there is a change in the transport of marine litters turning in the westward direction due to the high zone of velocity. So that is for the hydrodynamic data. Now, over the next 20 days, ocean velocity winds will continue to direct particles towards the northern part of the region. So as a result, we can see that there is a change in the position of the particles, but there is also some accumulation for where the particles are first observed. As I said a while ago, we have this clustering. Now, these centroids are now depicted in here, and we got the convex hull of displaced particles using the representative points from the DB scan to determine the affected communities while evaluating the marine fare. So these representative points indicate the approximated affected areas, and the area of the polygon here may be used to assess the extent of marine litter transport during the specified period. The results indicated that despite the passage of time, the amount of litter in Palawan region, so Palawan is the one with the highest tourist yearly in the Philippines, there is significant accumulation here, which is an important concern for not just in tourists but also for fisher folks and people living in there. Excuse me. Now, determining the extent of marine litter involves carefully selecting 6 observation points. So these are arbitrary. So we have here 6 islands, so it's there. To evaluate the amount of litter within a given threshold ranges, a buffer area with 10 kilometers is created for each of these points. Now, the figure that you can see in here, the one that is adjacent to Ramblon Island, I think it's the volume, it's the brown one. Yes, it's the brown one. Typically migrate away quickly because it also has a smaller percent of marine litter. While debris around Snake Island, with the highest percent of marine litter, remains longer. So this shows that transportation of litter impacts not only the source but also the surrounding communities. And controlling marine litter in the short term is crucial as it tends to oscillate and return to coastal regions. And it's not just that, we also need to consider the socio-economic and logistic measures to establish a sustainable coastal management system. Now, what are the key takeaways? First, it is imperative to recognize that marine litter management is not a problem that can be tackled. It can be tackled by a single entity, but the realistic approach is to tackle it not just by a single entity. So that is the key takeaway from this. And aside from computational and engineering-based methods, multidimensional attack is required to address the management of litter. So first we have the social science side, and we also have the business and evaluation side. So marine litter is a global issue that requires collective action from individuals, governments, and organizations. So we have to also include them. And the responsibility for the actions is shared, and different entities must work together to conserve both these ecosystems. So that is the end of my presentation. Thank you very much.
Are there any questions? Please ask.
You mentioned that you have a formula that can be solved and that shows the path of the rivers traveling. Could you please tell a little more? How did you prove this formula? Did you monitor the river movements with any kind of satellite flights or plane photography to compare it to each other?
I think that's a good question because it's in the paper, but I did not mention it in this presentation. So this litter are just artificial statistics I mentioned. So this is not new data that we captured from satellite data or from existing historical data. So yes.
Okay. Yeah.